there's some exciting questions we can ask, about Mars. Was Mars ever a place for life? Was it ever inhabited, or was it just habitable? And the rovers have collected some really tantalizing samples. But bringing these things back, it's a tall undertaking. It's an expensive undertaking, and it's going to take years.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
The world needs evidence-based public policy now more than ever. Making the right decisions should not be partisan politics. Please help spread The Rational View by going to patron.podbean.com/The Rational View. Together, we can make a better future.
Hello and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I'm interviewing a scientist turned science fiction author who's written a book that takes the reader on a journey around the solar system to the many remote places we visited with our space probes. And I'm eager to learn what he thinks about space exploration as something that humans might want to do in the near future. If you enjoy what you're hearing, please press like on your podcast app, share the love, and come visit me at patron.podbean.com/The Rational View. Dr. John Moores is an associate professor in the Center for Research in Earth and Space Science at York University. He's a member of the Royal Society of Canada's College of New Scholars, Artists and Scientists, a recipient of the Canadian Aeronautics and Space Institute's McCurdy Award, and served as the science advisor to the president of the Canadian Space Agency from 2022 to 2024. John holds a BASc in Engineering Science from the University of Toronto and a Ph.D. from the University of Arizona in Planetary Science. An author on over 100 articles in Planetary Science, John has been a member of 5 NASA and ESA-led space mission teams. Welcome to The Rational View.
Thanks for having me.
So you may not know it, but you and I have a lot in common. You were introduced to the podcast through our mutual friend, science fiction author Eric Choi, who I've actually had on the podcast earlier, and you're associate professor at the Crest faculty at York, where I'm an adjunct. So very cool. You were also science advisor to the president of the CSA, and I was not.
well, there's got to be some differences, right?
So tell me, what was that like being science advisor to the president of the CSA?
Oh, it was really fascinating. I love interdisciplinary stuff, getting to know areas of study and areas of research that are not my own. And one of the lovely things with the Canadian Space Agency is that they manage a portfolio of different space missions that cover 7 different scientific areas. I come from planetary science myself, and I know a little bit about astronomy. I spent some time with Environment Canada, so I know a little bit about some of the earth science stuff. But it was really neat to just jump in and learn so much and be able to be an advocate for the kind of great science that we were achieving in space.
So what would you say is your legacy as science advisor over that period? How were you able to shape the policy of the Canadian Space Agency?
Well, I think the key word in the title is advisor, right? So I'm there to give advice and to give that outside view, right? Because I'm an academic. I come from York University, and what they were interested in was knowing, what does the community think of some of the things that we're doing, and how can we best set things up, to engage with them. Mm-hmm. So, I provided my advice. And, the folks who were at the agency, it was their job to integrate that advice with all of the other concerns and considerations that they had. So, sometimes, it went along the routes I suggested, and sometimes not. And that's how it goes. That's how it's supposed to go.
Excellent.
So, I like to think that, I provided some, helpful opinions, and that, maybe I can't point to something and say, that was me. But I think that, what was going on while I was there, I feel like I helped to make it a little bit better.
Excellent. I mean, that's what you're there for, and I hope that the CSA continues to choose science-led projects for their exploration. You have a new book out called Daydreaming in the Solar System, where you bring the readers to vicariously live little vignettes in various remote solar system venues. And each vignette is followed by a review of the scientific data upon which the short story is based. From a scientist's point of view, the hard science makes this a very interesting read. I enjoy, looking at all of the details and how we work these things out and what the data is that sets this up. Why did you decide to write the book this way?
Well, when Jesse and I first started talking about this back in 2019, we were both doing a bit of science outreach, a bit of science communication, and we were both big fans of science fiction. And what we had really wanted to do was to find some way to combine these things, to take from science fiction that engagement, that involvement you can really get, devoured in a novel in an amazing way, or your favorite TV series or a movie series, something like that. Meanwhile, we knew that sometimes in science fiction, things about the natural world get changed just a little bit in order to make for a better story. And so we wanted to have that kind of engagement, but using the actual solar system and the things that we'd actually discovered from spacecraft. So we thought this might be a useful vehicle to communicate the discoveries that we've made over the past 62 years of robotic exploration. So we have the vignette, and then, like you say, we have the hard science that explains how the vignette was able to happen.
I think you showed great restraint at sticking to the science in your vignette on the European Ocean. You had an explorer in the ocean, and you hinted at alien life forms, but you never went there to say maybe it was just a shadow. So, well done. That must have been difficult.
Well, it's interesting, right? Because we often get ahead of ourselves. We want the exciting answer, right? We want to discover life or to find something new, but we have to use restraint. Remember that, extraordinary claims need extraordinary proof. But fortunately, the third component of our book, the illustrator, was able to sort of bring the imagination, the daydream to life. So in Michelle's piece that she created for the European Ocean, you can see the tentacles of something surrounding the sub just out of view of the front window.
Ah, yes. So how difficult was it to place the reader in each situation? Was the physics relatively straightforward, or how much work did you have to do to get the science right?
Well, I've got a background in planetary science, so I sort of live and breathe this stuff and have been for 20 years. But something that I had not fully appreciated was that when we're exploring another planet, we're trying to learn about that place, we're not always trying to do it from a human perspective. So you might want to know what the composition of the atmosphere is. You might want to know various things, but the types of things that you and I might care about with our five senses, we don't always have that information. And to me, like one of the biggest examples of that that inspired the skydiving on Jupiter chapter is the Galileo entry probe. So the Galileo entry probe went into the Jovian atmosphere all the way down through, took wonderful measurements, gave us great data, no camera. So we have no idea what it looks like. But from the data that we collected from that particular probe, we can infer what the sky looked like, where the clouds were, what the situation would be like. And so that was what we were trying to do with the book, to take, this professional data and to translate it into human senses. And often Jesse and I found ourselves having to make a calculation of what something was really like how far can you see on the Venusian surface, things like that. What color is the sky seen from the inside, down right above the great red spot on Jupiter. So we would go and we would do these things, and it was really interesting. It gave us a new insight, I think, on these bodies that we've studied for years.
That's certainly something that scientists and outreach have to do a lot is to try to bring experiences that people can't have to make them human. Like I know from astronomy, like the Hubble, that they have the Hubble palette, where you're taking different invisible wavelengths and giving them visible colors so that people can enjoy the pictures that they're taking. But there's some artistic license. Where did you have to take artistic license in any places?
We tried as much as possible to avoid that. We wanted to keep things as close to the science as possible. There are, of course, places where you need a little bit of speculation. So we may have, joined the dots with a longer line than perhaps we would have if we were writing a scientific paper. And certainly there's a few places where there's a few sort of, little things that we imagine that are necessary to make the story work. So, for instance, there's one of the chapters on Venus where we go down to the surface. We imagine a suit that the astronaut has that allows them to be alive down there, and we base that off of essentially designs for robotic spacecraft to go and visit Venus. But at some point we wanted them to take a sample of rock. And we imagine them taking a nice clean sample out. And we are kind of, there's a kind of, winking and nodding at the audience there in that, this is a geologist. Whatever their fancy sampling tool in the future is, they don't know how it works. And so therefore we don't know how it works. And we actually tell the audience, that that our character doesn't know how it works, but it gets them a sample that they need. So we're able to try to focus on the science a little bit there, without getting into, those types of things, because there's a lot of tech that you would need to go and visit these places as if they're national parks, and to have it not be a survival kind of situation.
Yeah, no, that's true. These are not hospitable places in general. So I read through some of these things, and your vignette on Jupiter's moon Io. You didn't mention the one thing that I thought you might would be the radiation environment, because I know you did mention it when you were talking about Europa, that it was protected under all of the ice down there, but on Io not so much. So I think that I was looking like, I wonder how bad it is there, and it was like, oh, it's bad.
It is very bad, yes. and there's a certain amount of that, right? Like we have the challenge, I think, that we're wanting to represent these places in terms of the five senses we human beings have. But in order to go to a lot of these places and not die instantly, you have to have some kind of a spacesuit between yourself and the environment. And we tried to be clever where we could to find ways of bringing the outside inside so that we could make it known. And my favorite example of that from real life is that, we actually know what the moon smells like, for instance. And we know what the moon smells like because Armstrong and Aldrin went out on the surface. They got dust all over their spacesuits. They went back into the LEM. They took the spacesuits off so that they could sleep. And they smelled the strong spent gunpowder of the sulfur dioxide. Wow. So we actually have that kind of experience. So we took inspiration from that and tried to find ways of being able to engage a little bit more deeply with these environments without making it too ridiculous. But you're right. For Io, that's a very good spacesuit that our astronaut has.
That's a very good one. So, obviously you did a lot of work to research all of these different space probes and bring the science to it. What would you say is the most interesting or surprising thing that you learned in researching the book?
Oh goodness, there's so much with it. I think in terms of surprise, it's places where maybe we had expected something a little different. Maybe we were a little bit seduced by some of the science fiction that's out there. So not only were we thinking of the Galileo probe when we were writing the skydiving on Jupiter chapter, but I had also been thinking a little bit of some of Dan Simmons' novels. And in one of those, I believe it's Rise of Endymion, there's a scene where someone is teleported into a gas giant atmosphere and falls and falls and falls. And so I had thought, well, okay, your astronaut is going to achieve terminal velocity, and so they might be able to fall for quite a long time. And when I did that calculation on Jupiter, they don't have that long to fall, actually. They fall extremely quickly because of the composition of the atmosphere, because of its density up high. And the challenge in some of these places is actually, how do you get enough time with the scientific target you're interested in? So on Jupiter, you need more time. So you need a good-sized parachute, which is what the Galileo entry probe had.
Yeah, that's interesting.
If you go to Titan, it's different, actually. Huygens needed a couple of different parachutes, one of which was smaller so that it wouldn't spend so much time in the atmosphere that Cassini-Huygens, which was how it was phoning home, would pass over the horizon. So it needed to get down quicker.
This is the European Space Agency probe that dropped a lander into the atmosphere of the moon, Titan, Saturn's moon, with all the methane atmosphere. I don't know if you remember, but they had a big problem in the engineering of that space probe because they hadn't accounted for the Doppler shift of the spacecraft leaving with the frequency that would communicate the data back and forth. So it was quite a scramble to figure out how they would get the data back. So, but a great job on the team to do that.
Oh yeah, like I was at European Space Operations Command for that. That was my one of the first missions that I worked on. It was really an exciting atmosphere, I have to say. But you're right. We had challenges with the spacecraft, and I can tell you the day that it landed and we were getting the data back, we knew early on in the day that something was wrong. One of the transmitters, one of the receivers on Cassini wasn't getting the signal. It hadn't been turned on. So we were getting back half of the data, and sort of a random half as we were coming down through the atmosphere. And I can tell you, going into into our area that day, even though we were getting the first images that we had ever gotten from Saturn's moon Titan, we were initially pretty depressed,
Right.
because exactly, and then this is a mission that had been like I'd only just become a grad student a couple of years before. I was there fairly recently, but most of the people on that team had been there for decades. This was their life's work. And so, I think that was a little bit heartbreaking for them. But eventually, we got down on the surface. We could see the surface getting closer and closer, and then, all of a sudden, it just flashes up that image looking out to the side, where you see the rounded pebbles and whatnot. And there was excitement then. It was palpable. You could see people counting off on their fingers. And I think what they were doing is they were trying to figure out which human being had been the first to see the surface of Titan. And it was exciting to be there in the room at that time. And then later on, as we got to analyze the data and we realized how much we had, I think we all, started to feel a lot better about the mission. But yeah, you're right. Some of those little errors, like that receiver. There's another thing with Huygens in that the vanes on the spacecraft might have been put on the opposite way because the spacecraft rotated in the opposite direction than what was expected, which, changed some of the science we got and the way in which we got it.
Wow.
But, these things happen on space missions. They rarely go entirely according to plan, but they still bring us back these amazing views, this astounding new data. We get to know a place in a way that we hadn't before.
And the amount of care that's taken for robotic space probes, often decades of development going into these and testing, it's an order of magnitude less than what you need to put into a manned space mission, where you need to ensure the survival of the crew. I mean, we lose robotic space probes all the time. If you count the fraction of Mars landers that have survived, it's less than 50-50, I think.
We're getting better.
That's not really acceptable for manned missions. So I think the theme of your book, presenting people in these environments, is kind of what makes manned exploration interesting to the general public. The chance to view themselves as the explorers on these worlds, rather than, yes, the robots are great, but having people there gives it kind of an exotic allure. But many scientists that I speak to are very opposed to manned exploration because it eats into the scientific budget quite a bit because of the order of magnitude extra work you need to do to keep these squishy carbon water bodies alive in a very, very harsh environment. Do you support manned space exploration? What's your position on that?
I think you need both, really. Having humans generates a lot of excitement. It generates a lot of inspiration. And that's why people get into space exploration and actually get into STEM fields and go out and do other wonderful things that help society. So I don't think you can get rid of the human side of things. The other side of it is a cultural one, right? We've had people who've been to the moon who have, come back and have been able to share what was that experience like. And so this is an environment that actually lives within human culture in a way that the planets don't, at least not yet. So I think you need a little bit of it, but you're right. It's the robots can definitely go further right now. We can make them expendable in a way that a human mission can't be. So, the two, I think, are actually synergistic with one another. And if you look at things like the Artemis missions, the plan is to have both humans and robots there, each doing what they do best and helping each other out.
Interesting. So along that line, what do you think of Elon Musk's claims that he's going to establish a settlement on Mars?
Well, the one thing that I always like to say when it comes to exploration is that we often think of explorers as individuals, Shackleton or, Neil Armstrong or whatnot. But really, exploration is something that societies do, right? The resources that are required to go out and make the unknown known are, beyond any individual, including very high net worth individuals. So, and of course, those people made their money as part of society, developing something that people wanted and were willing to pay for. So, no one is completely divorced from other people. So in terms of, people wanting to go out and colonize Mars, if it's something that we choose to do, it's probably something that we will choose to do together. I don't think Elon Musk even has the funds to do this completely on his own. So presumably he would be hoping that that NASA helps him out or other space agencies help him out as well. But what he has done is he's taken on some of the risk, with his personal money, developing, the Starship and, some of the equipment. And, he's developed plans and he's put together a company that could perhaps, go and action those things. But it's something that we have to decide. Is this the way we want to spend, our valuable time and treasure?
Yeah, I like to make parallels between the era of space exploration and the era of exploration of the New World, when European countries were sending ships across it, and even into the Shackleton expedition to the Northwest Passage. The scale is very similar in terms of the investments, in adjusted money that they were making back then. Like the two ships they outfitted for Shackleton's expedition, they went part way, and then they encountered another ship and reloaded halfway there, and then they went off, and they were a 3-year expedition or whatever it was supposed to be. With the latest in scientific equipment, and they had a science team on board. It's quite interesting to look at the parallels and also to look at what went wrong and how the successful explorations did go, and the difference between some of them is quite interesting, and what lessons we can take from it. What lessons do you have as an expert in all of this for the future? What should we be doing?
That's a good question. So I think we've got some options, right? The initial reconnaissance of the solar system, we've done a lot of that, and that's given us a lot of information. It's given us a lot of understanding. Mm-hmm. So what remains now is the more difficult questions that sometimes can be a little bit more costly to look at. So we might look at something like, for instance, Mars sample return, which is something that I know is getting a lot of scrutiny in the press, especially south of the border now. There's some exciting questions we can ask, about Mars. Was Mars ever a place for life? Was it ever inhabited, or was it just habitable? And the rovers have collected some really tantalizing samples. But bringing these things back, it's a tall undertaking. It's an expensive undertaking, and it's going to take years. There was a report recently that suggested that NASA was perhaps underestimating how much time and how much effort it would require to bring these back. So now we're thinking more like the 2040s. So I think there is value in asking those big questions and being able to go after those big goals. And one of the things I really like about the planetary community and about a lot of the scientific communities is that they're not afraid to sort of sit down and, to hash it out with each other, to try to figure out where are the big places to go, what are the best questions to ask, and how does that relate to, ourselves and what we want to learn about the universe and our own origins.
It's very interesting. One thing that I've asked, and I did some presentations, but it is discussing what should be the goal of future manned exploration. I think in the past, one of the reasons why a lot of scientists aren't on board with manned exploration is that it's been touted as scientific led. But if you wanted to be the most efficient at science, you would not send people. You would send robotic explorers. You would get more science back. You get more papers per dollar from the robotic missions. The manned missions, I think the benefits to them so far have been social in nature and inspirational, in getting people into STEM fields, in supporting that, and in international diplomacy. Like all of, if you look at the International Space Station, it's not what anywhere near top science producing laboratories in the world, but it's definitely dwarfs all of them in price. So, and that money all came out of space science. It was because they sold it as a science thing rather than an international diplomatic effort, which is what it really was. I find that issue, that dichotomy is maybe a problem for how it's being sold. What do you think the purpose of manned exploration should be?
Well, I think that inspiration is a big part. That idea that, we can take on, big challenges. I really like, what you were saying there, talking about, for instance, diplomacy. Here's a place where, countries can compete and can show that they can, create and deploy and work with advanced technology. So I think there's some strong advantages to doing that. Another argument that I've often heard is that because of the strong inspiration potential of human exploration, that's what allows you to have a robust scientific exploration alongside. And when you look at that, like countries like the United States, for instance, that have that really strong history in the human exploration side of the portfolio, they usually accompany that with a really strong investment in the science side of the portfolio as well. And it's not that we don't do that in other countries, but the scale is quite a bit smaller. When you're looking at, the dollars per citizen spent in the United States versus in Canada, for instance, it's almost a factor of 7 on a per capita basis there.
Yes.
And so, the Americans are able to do more.
Yeah, no, true. Very, very important. The difference in per capita spending is stark, and the fact that there's also an order of magnitude in capita.
It's true.
Especially stark. So your book is out now. It's available. What's next for John Moores? What are you working on?
Well, I continue to be a professor at York and doing my research and, educating students and anybody who's interested in space science and space engineering. Hoping to write some more of these books. That's what I'd like to do. I really enjoyed putting this one together, and we might at some point write a sequel to this one. It'd be fun to go out to exoplanets, definitely, because this one stays entirely within the solar system. But there's other topics of great interest as well that I think there are lessons on the planets for those that we can bring home here. So one gas I find particularly interesting to look at is methane, because on a place like Mars, or even on some exoplanets, methane might be an indicator that there's life-associated processes going on. Certainly on Earth, most of the methane in our atmosphere comes from life-associated processes. Not all of them in the bowels of cows, but you've got this interesting microbial metabolism going on.
Sure.
On the Earth, it is a bit of a different story. So on the other planets, methane might be evidence that life exists. But here on the Earth, we have troubles with too much methane. Methane is a very potent greenhouse gas. Mm-hmm. And so its emission into the atmosphere is making, changes in the radiative balance of the Earth, helping to change how things happen. And this is something that's happened before. The biggest mass extinction in the Earth's history actually was the result of too much methane in the atmosphere. So it's got this interesting dual role. And I think there's lessons as we move forward here on the Earth out there in the cosmos as well.
Very good. Well, thank you so much for joining us today and talking about your book and your work. Very interesting. Love talking to you. If you'd like, I'll send you a Rational View t-shirt for spending your time on here. And thanks for sending me a copy of your book.
Thanks so much. Great chat.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.